Hi there, and welcome back. As promised, I wanted to take a moment and show you what the graphs of some of these exponential functions that we've started discussing in section 5.1 look like in the context of the two graphing utilities we've been using predominantly throughout the semester. So, for starters, let's go grab the Desmos graphing calculator. That's probably the one you'll have readiest access to at the moment, unless you happen to have a TI graphing calculator sitting right there beside you. So I've got a setup here for some of the examples as they appear in our notes handout. So again, I take that for granted that it's there. So I have y equals 3. If I'm wanting to do an exponent, I need to hold down shift and hit 6. That pops me into the exponent, and now I've got y equals 3 to the x sitting right there. You should be able to see the graph window just in case. Remember, come hit the wrench. Pops up what we got right there. So pause for just a moment in case you want to take a look at it. So that's sort of the default setup for the Desmos system. You'll notice again it marks out the y-intercept for us right there, 0, 1. So if we tweak this a little bit and do 5 times 3 to the x, like the next example that we've got sitting in the notes file, it's going to look like that. You'll notice it's gotten a fair bit steeper. So if you'd like, you can even graph them, one after, as you say, one on top of the other. So let me do that. So there you go. So you can see the blue 5 times 3 to the x graph is climbing much more sharply than the one that we've got right there. So that's one setup. I did want to show you Desmos is also aware of the special number e that we talked about previously. So it even gives you, the little decimal approximation right there. E to the x generates the graph right there. You can see there's again y-intercept. If you come to x equals 1, you can click on that guy and see, hey, there's that 2.718 that shows up in the notes handout. All right? All right. I also wanted to take a moment and show you what's going on inside a TI graphing calculator. So the setup there, before we talk about the graphs, I did want to mention, just to make sure if you're looking at this in terms of setting these guys up, I had promised the second function of this guy right here gives you e to a number. So if I just do e to the first, close up my parentheses and hit enter, you see, hey, there's that 2.71828 guy that I've discussed earlier. So if you just needed to do an exponential by itself for a different base, so you needed like 3 to the 8th or something like that, the key is right here above the division symbol. So hit enter, you get that. Congratulations. So if we're wanting to sketch a graph, I'll put in that same 3 to the x, so 3 hat, and I hit my x variable key right there. Before I draw the graph, I'll show you what the graph window looks like. Again, remember, if you want to adjust that, it's right here. Hit that window button, and you can see the range basically looks the same as I had it set up inside Desmos. So my graph looks like that right there. I could do the same thing if I go back and put in 5 times 3 to the x. And the graph adjusts accordingly. So again, it matches up with what we saw from the blue guy in the previous example. So those are exponential growth functions. If we wanted to do exponential decay instead, I'll take a look at the 2 examples that pop up in the notes file from there. Let me clear you out. This range will work more or less fine. So we've got 3 times 2 to the, now to get the negative x in there, I recommend using parentheses, like I said, negative x. Again, remember, we want this key. If you hit that one, it's going to try to do a subtraction and it won't know what to do with it. You'll get an error message. So let's take a look at our graph there. So it's quite flat. So you notice, as opposed to the growth functions that were going up, up, and away as we let x get big, now we're shrinking down and getting closer and closer and closer to 0 as we move in that direction. So if you wanted to see what's happening here, it's kind of a mirror image. The graph is actually spiking a fair bit back in the other direction. So you could do it that way. Let's take a look at the other guy. So we'll clear you out. The other example that we give you is one where instead of having a negative exponent, we just work with a base value in a that's between 0 and 1. So we've got 2/3. Again, note the parentheses. If you don't put them in there, the calculator is going to do 2 divided by 3 to the x. That's not what you want. So let's take a look at that graph real quick. And it's even flatter. I'm going to have to scale this a bit if I want to get a decent picture out of this. So I'm going to come in here, change my graph window. Let's shrink that down to like 5 instead of 30. See if that still pretty shallow compared to what we've seen previously, but you can get that sort of mirror image idea. Looks like it's flying off in that direction, off this way. It's tapering down towards 0. So if you're doing one of these guys inside Desmos, coming back over here, let's take a look at what they look like in the Desmos setup. So we have 3 times 2. Again, shift 6 gives us the exponent. 3 times 2 to the negative x. So again, matches up with what we saw in the calculator display previously. We come down here, y equals, again, remember you're going to want 2/3 in parentheses. Get into our exponent to the x, and you see the blue guy, he's super duper flat, but the blue and the red lines are running really close to each other right here. Hey, look, there's a point of intersection where they end up crossing. That's not particularly important, but you've got it. So that's graphing using either a TI graphing calculator or the Desmos online calculator. So I've got one more video where I want to take a look at this. What happens if we're actually having to build one of these exponential functions rather than simply being given one and being asked what its graph is or what to get if we plug a particular x value into it? That's what we're going to be taking a look at in the next video, so stay tuned.